So let me begin with a couple of background sentences on the presenters for our first session. It will be presented by Mir Ali and Paul Armstrong. Mir Ali is currently professor and chairman of the Structures Division of the School of Architecture, University of Illinois at Urbana-Champaign. And he has written a number of books and has worked in this area for an extensive period of time. His new book, The Skyscraper and the City, Design, Technology, and Innovation, is co-authored by Lynn Beadle and Paul Armstrong, and will be forthcoming soon. And Paul Armstrong is a registered architect and associate professor and chair of the design program, School of Architecture, University of Illinois at Urbana-Champaign. Paul Armstrong co-teaches with Professor Mir Ali. They teach together a graduate seminar entitled High-Rise and Habitat, and is very active in a number of other areas related to sustainable tall buildings. So let me turn it over to our presenters.
Okay. Thank you for the introduction. Okay, good afternoon. The topic of our presentation is recent developments in sustainable design factors in high-rises, which is basically an overview of sustainable tall buildings. We have introduced a number of ideas and concepts, and at the end we will present some case study examples. By the year 2030, about 5 billion people will live in urban areas, and this is according to the United Nations, and 60% of world population will live in urban areas. So that tells us that there will be a dire need of building more tall buildings, because land is very expensive, as we know, and we don't want to expand horizontally because then it creates other problems. So it will be inevitable to build new tall buildings, even though there are some people who don't like it. The issues to address will be the energy needs, global warming, pollution, urban sprawl, water shortage, and of course global conflict, because when there are too many people, there are many social and economic and other problems that automatically crop up. Here is a brief history of sustainability. It actually started the way we know it in the early 20th century, although even before that, people always, by instinct, would follow the ideas of sustainability to have a comfortable living in whatever way they could. But as we know it, the agricultural and forestry theories, they started this. The people who are in agriculture, they thought about sustainable yield and renewable resource management. And then, of course, architecture also jumped into the bandwagon to celebrate the industry and technology. And of course, something called vernacular architecture, which is very local type of architecture, local type of design, that has to do a lot with sustainability. And then the 1973 energy crisis after the oil embargo, that also, I think, prompted what we have witnessed in the recent past. And of course, the solar architecture was a slogan at that time, but then after some time it sort of died down temporarily, and again it came back in 1989 after a report which is known as the Bartland Report, Our Common Future, and of course it was published by WCAD. And then this was reinforced by the Earth's Summit at Rio de Janeiro that was held in 1992. You can see the situation that's going on right now. These are the population figures of the various cities, and there are more. We just listed 10 of them. There are other cities, and you can see Tokyo starts with about 35 million, and then New York, Seoul, Sao Paulo, Mumbai, and so on and so forth. and it will only get worse because people move from rural areas to the cities, and of course in the developing countries, mostly in the developing countries, population is increasing at a very dramatic rate. Sustainable design for high performance encourages wise and prudent use of renewable resources, creates alternative strategies for energy production and conservation, uses environmentally friendly design, applies intelligent building technology, promotes integrated design. So when we talk about sustainability, particularly in the context of tall buildings, there are quite a few issues, and you can see we are adding this intelligent building technology, which is very much needed, and of course integrated design. Integrated design is really a good part of sustainability, because if we want to really make a very complex system like a tall building sustainable, then integration of the systems in a very effective and efficient way is of utmost importance. The concept of sustainability emanates from economic development, environmental protection, social justice and diversity, consistent resource demands of technology and social organization. Now, what is a high-performance tall building? These tall buildings optimize energy usage, structural materials performance, and environmental and interference effects. The goals are increased energy efficiency, comfortable, safe, and enjoyable work environments, and easy maintenance within a reasonable budget. Now, I must tell you that there are three things that go kind of hand in hand, and sometimes we get kind of mixed up. This is under the broad category of sustainable design or green design, and these are basically the high performance tall buildings, and then another category we can say the carbon neutral buildings, and of course we have the zero energy buildings. So sometimes these are different categories. We use these names, but they are not totally mutually exclusive, and they fall under the broad definition of green design. Therefore, we really need a completely global view of things. Now, when we talk about integration, of course, there is some high initial cost to integrate. And it's very hard to measure, and I talked with many people personally who have dealt with some of these issues, and nobody can give an exact figure, and some even said that if you do a sustainable design and if you do it smartly, using passive techniques, in fact the cost may be lower than a regular building. I even heard that. But others say it is 1 to 2%, but we believe it's a range. It's probably it can go as high as 10%. It could be 5% and so on and so forth, depending what we are integrating. Now, we developed a sort of integration web that show the interrelationships of all the subsystems in the building. So there are some major systems like mechanical, of course architecture, mechanical, structure, and then plumbing, etc., electrical, and then there are some subsystems, and we are showing through this diagram the interrelationship, which is really very complicated. And we got this idea from the food web in a way, and also we looked at some integration chart of aircraft structures, which are extremely complicated. And this shows in a tabular form the same kind of thing. I'm not going to go into detail because of time. So here we have presented those in a very tabular form, and we emphasize integration for sustainable buildings, as I said, because integration is one of the key factors that makes a building really efficient and sustainable. Now, knowledge and technology transfers, basically we can learn from other industries like the automobile industry and also the aeronautical industry and even the space industry, but it's a bit too far maybe, but the aeronautical engineering and automobile industry, these give us some decent ideas about how we can use some of the information. They may not have exact similarity, one-to-one correspondence, but we can somehow learn from those and apply to tall buildings, because tall buildings are a very complex system, and they have, it's also multidisciplinary and so on and so forth. Now, LEED rating system has this evaluation criteria, and you all, most of you know about this, so I don't have to go through the details of this. Now, what are the strategies for achieving sustainability? If I can go back, something that we didn't see in this list is the emphasis on ecological sustainability and also community development. I think these are areas that need to be looked at a bit more closely because they are very important. The community development is related to the social aspect, and ecology is of course very important, but we need some sort of more explicit inclusion of those ideas. Strategies for achieving sustainability, of course we can use the passive solar gain, and there are different techniques here. You will also find it in the paper, so I don't want to go through everything because of time again. We have a limited amount of time, but passive solar gain is a very important component of sustainability. Now, structural materials, when we say high performance building, we are also dealing with safety. People should be safe inside, and the structural performance and the material performance should be at their peak. So core is an important element in the building which deals with structural stability. We often use the core for structural lateral load resistance, and then of course it deals with all the mechanical systems, elevators and all that. So it's a kind of hub of integration. That's where much of the integration takes place, and we can make a building sustainable if we pay a lot of attention during the design process about the core. And then steel frame construction. Steel is of course a recyclable material, and however it demands a lot of embodied energy. Now, reinforced concrete is also widely used at present. You can see the Burj Dubai building right here, the tallest building in the world, and many other buildings. And it has the potential of getting recycled. The particles, the concrete elements from a demolished building could be used for pavements and other types of applications, but I think more research is needed in that area. And of course, mixed steel concrete construction, that is more popular these days because we get the advantage from both steel and concrete in this type of construction. Smart materials and nanotechnology. Side by side with sustainability, this is also another aspect, the smart materials, because we use all these smart materials and sensors and many high-tech concepts to come up with a sustainable building design. And these are some of the items that we have listed. And then of course the carbon fiber application of that has been already introduced into the aircraft industry. And there are some positive and negative sides of it. And Peter Testa, who is an architect in the West Coast, he designed a visionary project which is a 40-story carbon tower, and you can see how it is, but a real application of this using carbon fiber in a building is probably decades away because of the cost involved, and there are some negative aspects of it, even though it uses nanotechnology. But I kind of did some research on that, and we found that carbon fibers tend to be a brittle material, which is not always good for buildings. We need more ductility and deformability in buildings. And then facade technology is another aspect of sustainability, coming up, designing facades, and again, this is another place where integration becomes important. The ventilation, mechanical system, and rain screen principle, all these things kind of come together, and solar panels these days. We can use the facade for solar panels, which will, in a way, serve two purposes. So the facade technology is gaining a lot of attention these days, and we use a lot of shading and this kind of devices, and how to avoid glare, how to use sensors so that when the sunlight is very bright, it will automatically become dim and people from inside would not get the glare, things like that. And then of course there are other aspects. We can use it for aesthetic expression, and then it controls the environmental conditions. And there are double or triple skin facades these days which are used to create ventilation, create pressurization within the space, and that inert space is sometimes filled up with argon, and it gives us a lot of energy saving and ventilation and comfort in the building. Harnessing solar and wind energy. I think you all know about the solar panels, solar cells and solar panels, and it's cost effective, but it's gaining more and more popularity these days. And then of course the wind energy is another thing, and for tall buildings both of these are good because tall buildings kind of shoot up above natural landscape quite a bit, and it can get plenty of sunlight, and also it can get plenty of wind when there is high wind. So there is a great potential for that, but again there are negative aspects of it, cost, and maybe for the wind turbines, vibration and noise, those things have to be also considered. But a lot of research is going on, and there are all kinds of turbines now, vertical axis turbines, horizontal axis turbines, and all these things. So these things are becoming popular. Now one concept which is called combined heat and power, CHP, which is used in many European cities, but not so much in the United States, is gaining much popularity. And you can see an image here, a CHP station. The advantage of this is kind of sort of carbon neutral. It reduces carbon emission quite a bit, and also the electricity and power, electricity and heat, they are generated near the building, and because of that there is no transmission loss. So this is something probably we will see more in the United States in the near future, and as I said, it's also reduces carbon dioxide emission. Fuel cells are another important elements, and these have been used, of course, for many other applications. In airplanes they use it, spacecrafts, and now they are being used in tall buildings and buildings. And I think these are very neat because again this is a clean system, carbon neutral, it doesn't emit any carbon dioxide or greenhouse gases, and it's a very simple in concept. Basically they use a reformation unit that uses methanol and changes it to hydrogen as a fuel source, and then the hydrogen as a fuel eventually gets into the fuel cell where there is a chemical reaction, electrochemical reaction that generates electricity. I mean, this is another important thing. It's quite efficient, somewhat prohibitive in cost these days, but again it's getting more and more affordable. And these are different types of fuel cells. Other strategies are effective elevators. These days, efficient elevator, the destination-oriented elevators, those are being used. And then biomass energy, geothermal energy, I heard the rain already, so I have to move on real fast. And of course, intelligent building systems is controlled by the building management system, of which BMS is a component. And how we measure performance, that's a big question. We can talk about sustainability, but many of the buildings are just new or recent. Nobody knows how they are going to perform, so we have to watch and see. And there are issues of monitoring, and they are not easy all the time because of various reasons. And there are, here we are listing some buildings in Europe. Here are some case studies. The Menara Messiniaga, this is a bioclimatic design by Ken Young, which is another aspect of sustainability. and then Swiss rebuilding in London, which depends on aerodynamic form and many other concepts, which again you will find it in our paper. It has a diagrid facade, and then the Condé Nast building, which is the very first sustainable or high-performance building in the United States, and it's really very efficient and good, but again we have to wait and see how it performs in the long run. Here is another apartment building in New York City called Soleil, and another recent one is the Helena, which is a high-performance building also in New York. So these are some of the examples, and of course you have probably seen this before. Pearl River Tower, this is also a zero energy building, and the trick is, you know, the wind turbines and chilled ceiling and solar panels, almost everything is used, so it generates its own energy. And then in the conclusions, we will say, I already mentioned that initial cost, the lower long term, I think I'll skip that. The zero energy buildings, I think I mentioned that also. And it could be interactive power grid with buildings generation system. In other words, if there is excess energy generated in the building, it can be switched back to the power grid. So in a way, these are like batteries that can generate electricity for its own use and also can deliver electricity to the power grid for the city. And then the last one is, of course, we need 60% global cut in energy consumption, and then building single greatest indirect source of carbon emissions. Someone said it's about 40% or so. And then towards a sustainable world, these are the last words. Tall buildings draw massive amount of energy, obviously, and legislative measures and mandates are necessary at local, regional, national, and international levels. I mean, there are some issues like credits and incentives, but I think more mandatory requirements should be introduced in our opinion. Thank you very much for your attention.